Okay, write a Java program to calculate the power of a given number. Let us say that I have a number 2 and I have to find the power of 4. So this is the problem. So mathematically we know how to proceed with this problem. It's very easy, right? So it is going to be what? 2 into 2 into 2 into 2. Right? The output is going to be 16. So this is how we can approach this problem mathematically. But what if I want to use the Java programming language to solve the same problem? Right? In this case, if you observe, the code is getting executed repeatedly. Right? First observation, the code is getting executed repeatedly. Right? The second observation is we can see the number of iterations here. So the number of iterations is also fixed. The number of iterations are also fixed. So we can simply use the for loop. In this case, we can simply use the for loop. If you find any program solving statement, if you find the code is getting executed repeatedly, and if you also find the number of iterations are fixed, you can definitely go for the for loop, right? In this case, I have two inputs, right? One is base. I can take base as 2. I can take power as 4. So here this power is representing number of iterations that the program has to go through. So if the power is 5, the number of iterations has to be 5, right? So Java, this is how the problem could be solved in Java. Let me take the same problem statement, 2 into 2 into 2 into 2 into 2. So this time I have to find 2 to the power of 5. This is how we can approach. Firstly, we have to find the value of 2 into 2, right? It is going to be 4, and again 2 into 2 into 2 into 2. The resultant number and again has to get executed, and it has to get multiplied with the next number, and it is going to be 8 into 2 into 2 into 2. The resultant number has to get executed with the base number. It is going to be 16 into 2 into 2, right? And again 32 into 2, at last we got what? 64, right? So in order to perform this, each and every time the result has to be stored in a specific integer. Each and every time the result has to get stored in a specific integer, and the same results needs to be used to multiply with the same number. So every time the result is getting multiplied with the same number, right? So I am initializing the value of result is as 1, right? I have got base, I have got now power, I have got the value of result. I'm going to initialize the value of result as 1. So let's write a simple for loop. So for, you take this example, right? The iterations are nothing but, so this is first iteration, second iteration, third, fourth, 5. So for loop, the initial boundary is int I equal to 1 and run till I equal to 5, right? Inside the for loop, so what I'm going to do, I'm just going to take the base number. The base number is 2. I'm multiplying the base number with result, and I am saving the result in the result itself, right? So first iteration, the value of result is 1. So 1 into base value is 2. So first iteration, the resultant value will be updated to 2. Second iteration, again the updated result into base is going to be 4. The resultant value will be updated to 4. The third iteration, resultant into base 8. Resultant value will be updated to 8. Fourth iteration, the resultant value into 2. Right, 16. The resultant value will be updated to 16. And fifth iteration is the last iteration. The resultant value will be into 2. It's going to be what? 32. So the value of 2 power 5 is what? 2 into 2 into 2 into 2 into 2 is going to be 32. So at last, print the output in the system.out.println or print the result. The output is going to be 32. So let us solve this problem programmatically. I hope this logic is making some sense. Let me open my STS. Right. So let me take a separate method, static method, static void, and here I'm going to use the name of the method as power of number. Right, it is going to take two inputs, integer base, integer, right. So I'm taking a new variable, result, user defined variable. The name of the variable is result. I'm initializing the value of result as 1. Right, since it is representing the integer value, let me use the data type as integer. Data type. So again, if you see this, whenever you find the logic, whenever you are trying to find a logic for a given problem, when you find if the code is getting executed repeatedly, and if you also find the number of iterations are fixed, then you can blindly use the for loop. Right. So I'm going to use for loop for integer I equal to 1, because the iteration starts from 1 and I is lesser than or equal to, right, power. So here power is going to define how many times I need to iterate this particular for loop. Right, if the value of power is 5, then this for loop gets executed for 5 times from 1 to 5. Right, and the increment should be I plus plus. Every time it should get incremented 1 time. In the for loop, I am going to write the simple statement, which is use the result and multiply it with base. Right? Save this to the result itself. Save this to the result itself. So here the result is equal to result into base. Then once the for loop got executed completely, print the result. Right. So let me give the inputs in the driver class, which is the main method. So I am taking integer base equal to 2, integer power equal to we will take 5. Let us pass these values. Power of number, base, which is taking 2 arguments, base comma power. Let us trace the output. Output is 32. So let me take the power as 6. It is 64. So there are no issues with the output. Okay. Let me take the base value as 3, the power as 3. The output has to be 27 now. 27. So it is working perfectly. So let us stick to the previous question, which is 2 to the power of 5. Right. So this power of number method has 2 arguments, which is base argument is 2 and the power argument is what, 5. So 2 comma 5. So initial resultant value is 1. Then the for loop is getting, as soon as the for loop is getting executed, right, it will check if 1 is greater than or equal to 5. So let me take the first condition as true. If the condition is true, yes, the first condition is true, and it will execute the statement that is inside the for loop. So these are things. This is the first instruction. First instruction will evaluate what? 1 into, because the value of result is, the initialized value of result is 1, 1 into base. Base is what? Base is 2. It's going to be 2. This 2 will be stored in the result. It gets updated in the result. The second time again the condition is going to be true, because this time I is going to be true. Right? So again here if you repeat the same process, 2 into the new value of result is 2 into base, which is 2, going to be 4. Right? Replace the result with 4. Replace the result with 4. Again 13, the condition is going to be true. Right? Here 4 into 2 is going to be 8. Replace the result with 8. Again the next iteration, the condition is true. 4 into, so this time resultant, the result value in the result is 8, right? So 8 into base is nothing but 2, so 16. So replace the result as 16. For the fifth time, again the for loop, execution of the for loop will be successful because the condition is true for the fifth time as well. So this time 16 into 2, so which is going to be 32. Replace the result with 32. Right? The sixth time it is going to be false. The condition turns out to be false. So this for loop, the instructions will not get executed. So the control will come here. So here we are just printing what result. What is the value of the latest result? 32. The output is going to be 32. Right? And if you ask me, this is the best solution for to find the power of given number. This is not the best solution. You can optimize this to a better solution, because the time complexity is more. So in the bit manipulations in the future topics, we will understand how to make this solution in a optimized way. So that can be solved in our future topics in the concept called bit manipulations. Through bit manipulations, the time complexity can be reduced and the program, the internal program logic can be made much optimized. That's all for the day. Thank you.